10.1 is use properties of tangents. Our objectives is define terms of a circle and use properties of tangents of a circle. Okay, for a warm-up, just to get used to ready for this chapter, you'll use these skills in this chapter. Go ahead and work and solve those problems. You may need a scrap piece of paper to do them on, but solve those equations. Okay, go ahead and solve those. I'll give you the answers when you get done. So solve for x on the missing variable. Here are the answers you should have gotten. Number 1 was 5. 2 was 6. 3 was 6. 4 was 4 radical 3. And 5 was -7, 3. Any of those you want to see? Any questions on the warm-up problems? Let's do number 5 together just to review FOIL. So what we have is y plus 2 squared. So 5 can be rewritten as y plus 2 times y plus 2 plus 4 equals 29. And then we would do FOIL, first times first, y squared, the outer times the outer, that's 2y, and plus the inner times the inner is 2y, so that'd be plus 4y, 2 times 2 plus 4, and then plus 4 again, equals 29. So then we would have, simplify that, we get y squared plus 4y, and then 29, we're going to take, subtract 29 from 8, that's going to be -21, equals 0. Okay, so you got to think of a positive and negative combination that multiplies to be 21 and adds to be 4. So 3 and 7, their difference is 4, so it would be y, I'll go up here to the top, y plus 7 times y minus 3 equals 0. Solve for y equals -7 or +3. Those are the answers. Questions? Okay, good. Moving on. Vocabulary. Circle is a set of points in a plane that are equidistant from a given point. So I have my point, all the points the same distance from that point make a circle. Radius. Radius is the distance from the center to a point on the circle. Radius, distance from the center to a point on the circle. A segment whose endpoints are the center of the circle and a point on the circle. That's a radius. Two circles are congruent if they have the same radius. Right. If they have the same radius, the circles are going to be congruent. Diameter is the distance across the circle through the center. There's a picture of the blue line is the diameter. It goes through the center of the circle. Chord. A chord is a segment whose endpoints are on the circle. The yellow line is a chord. Secant is a line that intersects the circle in 2 points. Line that intersects the circle in 2 points. The green line is a secant. The difference between a secant and a chord is a line segment. A secant is a line. It continues on through the circle. Tangent. A tangent is a line that in the plane of a circle that intersects the circle in 1 point. That's a tangent. Intersects the circle in 1 point. Tangent. All right, any questions on the terms? Everybody have them all? Can I go on? All right. You didn't have them? We can label these. The green line is a secant. This red line is a radius. The blue line is a diameter. Yellow line, chord. Purple line, tangent. Am I ready to go on now? All right. In the diagram, identify the part on the diagram. What is the center? What's the center of this circle? What letter is it? Gage. Yes, the center is C. C is the center. Okay, what would the secant line be? Faith. My letters are different?
Yeah.
Huh. Okay, well then you'll have to go, well let me look at the notes and we'll go off your notes then. It's not good. Okay. So ignore the picture in the PowerPoint. We'll look at the one on your sheet. The center is G. What would the secant line be? The secant line would be what, Carly? Yes, AB, with a line symbol over it. That's the secant line. What would be the tangent line segment, Jacob?
Tangent.
What's that? Can't name a line with 1 point. You have to have 2 points. EH?
No, CD.
Needs DH.
Okay, yeah, DH. The tangent line is DH. Diameter. Kayla, what would be the diameter? Say again? CE. Yes, line segment CE. Radius, Eric.
FG.
FG is a radius. Good. Chord. Give me a chord in the circle. Anybody? Kennedy, what do you think a chord would be?
GE.
That's a radius. GE is a radius. Chord has endpoints on the circle.
C.
Yeah, we could do CE, which is the same as the diameter could be a chord. You could say, instead of line segment AB, you could say segment AB. That means it ends at A and B. That would be another possibility for a chord. All right, any questions? All right, we're going to we'll do some of this. We'll do this later. Theorems. So some theorems from this section. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Alright, so we've got P, the endpoint of the radius is here, okay. If this makes a 90-degree angle, then we know that this line M, is a tangent. So tangents are perpendicular to the radius at the point of intersection. 10.2. If two segments from the same exterior point are tangent to the circle, then they are congruent. So in this picture, R is, let's go back here. In this picture, RS is congruent to ST. We've got a point out here. We draw the two tangents. Those two tangents from the same point are going to be congruent. Then you can use the other S. S is another. We move S in. We draw the tangents. Those lines are still going to be congruent. They're not congruent to the original lines, but they're congruent to each other. Questions? Okay. Some examples. Number one, we have to find x. How do you think I could find x? Aaron, how would I find x? Pythagorean theorem, right. So we would have, so at the side AC, you have to be careful. It's x plus 16. It's not 16x. It's x plus 16. So we would take x squared plus x plus 16 squared. No, that's hypotenuse, so I need to erase that. We would take x squared plus 32 squared equals x plus 16 squared. So that's going to be x squared plus, what's 32 squared? You guys have to help me out. What's 32 squared? Eric?
1024.
1024 equals, then we do FOIL on the right side, x squared, okay, it's going to be 32x plus, what's 16 squared? Is it 256? 16 times 16? Somebody do that real quick. 256, okay. So that's 256. Alright, now we've got to simplify, so we're going to have the x squareds cancel on both sides. And we're going to move the 256 over. Subtract 256 from 1024. 768. How many times does 32 go into 768?
24.
24? X equals 24. Alright, so x equals 24 is the answer. Does everybody understand what I did at this, going from this step to this step? I did FOIL. Let's review FOIL again. X plus 16, you can have an extra step in there if it helps you see it. It's x plus 16 plus x plus 16. That's x plus 16 squared. So when I do FOIL, I take x times x, that's x squared. Then I do outer times outer, so that's x times 16, so that'd be plus 16x. Then I do inner times inner, that's 16x, plus the 16 times 16, which was 256. Then I combine these two together to make them 32x, and that's how I got to that step. Let's look at the other example. Swimming pool. We're 36 feet from a pool. The distance from you to the point of tangency to the pool is 48. What is the radius of the swimming pool? Alright. So, how are we going to solve this one? Gunnar, how would I set it up?
Use Pythagorean theorem too.
Pythagorean theorem. Right, so we would have r squared, the legs, make sure you use the legs. The legs are the ones that make the right angle, so it would be r squared plus 48 squared is equal to, this side is r plus 36. R plus 36 squared. So we square everything out, so that's r squared plus, okay, you're going to have to help me out again. What's 48? What would 48 be? 2,304. 2,304 equals to, then we do FOIL. r squared plus 72r plus what's 36 squared?
1,296.
1,296. Subtract that from 2,304. What do we get? 1,010?
8.
8. So it's going to be r squared plus 1,008 equals, no, the r squareds go away. It's going to be 1,008 equals 72r. How many times does 72 go into that? 14? So r equals 14. Questions? All right. Theorem 10.2 example. JK is tangent to L at K. JM is tangent to L, circle L at M. Find the values of X. How would I find the values of X? Which principle am I using here? How are we going to find X? Yeah. Yes, we know that the tangents from a point are the same distance. This line is congruent to that line. So it's a matter of setting them equal to each other. You shouldn't be eating in here. So we have 4x plus 7 equals 7x minus 8. And then we solve. So that's going to be, we move the 7 over, negative 3x. We move the 7 to the other side, negative 15. So x equals 5 is your answer. Okay, number 2, it's the same thing. We'll just set it up. Number 2, these two segments would be equal, so it would be 5x minus 4 equals 2x plus 2, and then solve. Okay, and you solve that. Any questions on 10.1? Section 10.1. Okay, let's go to the next section then. 10.2. Find arc measures. Well, our one objective is to find the arc measure in 10.2. So we have some vocabulary. A central angle is an angle whose vertex is the center of the circle. Looks like this. Here's the circle. There's the center. And we have a central angle. That's a central angle. The vertex is the center of the circle. So this may be circle O. Right? If the measure of a central angle APB is less than 180, then A and B and the points of circle P in the interior of APB form a minor arc. All right, so this would be a minor arc. Let's see if they put a picture up here. Yeah, there they go. So AB in this picture is a minor arc. It's less than half the circle. Minor is less than half the circle. Everybody have the minor arc? When you do arc, you put an arc like you put AB and then you put an arc symbol over it, a little arch over it. That tells you. Okay, then The next one we have is the major arc. If 2 points A and B are points on the circle in the exterior of angle APB form a major arc of the circle. So in other words, so the red line is the major arc. You name a major arc with 3 letters, right? Because the endpoints go on are the first and last, and then the point in the middle goes in the middle. I couldn't call the red line major. If I was naming the major arc, I couldn't call it arc AB because I don't know if I'm talking about the blue line or the red line. So to distinguish between the minor arc AB and the major arc AQB, I include 3 letters. So a major arc is named with 3 letters. All right, so the major arc would be major arc AQB. Major arcs and semicircles are with 3 letters. Now, if the endpoints are a diameter, then we have the arc is a semicircle. So if we have, if we draw this line here, right, we would say that CD or arc CQD is a semicircle. All right? Questions there? Okay. More vocabulary. The measure of a minor arc is the measure of its central angle. The measure of a minor arc is its central angle. So in this case, the central angle APB is 30 degrees. So the minor arc AB is 30 degrees. The measure of a major arc is the difference of 360 and its associated minor arc. So if I were to find the major arc, the blue line, I would subtract 30 from 360. There's an example. The major arc AQB is 330 degrees in this picture. Do I have it? Two arcs of the same circle or of congruent circles are congruent arcs if they have the same measure. So if one measures 30 degrees and the others have this third measures 30 degrees, they have the same measure. Two circles are congruent circles if they have the same radius. Two circles are congruent if they have the same radius. Arc addition postulate. The arc addition postulate says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So it's just like segment addition. You got two arcs next to each other, you add them up, The arc they make, it's the sum of their measures. So here we've got arc AB plus arc BC equals arc AC. All right, now we're going to put some of this into practice. MQ and NR diameters determine whether the given arc is a minor arc, major arc, or semicircle. So I'll give you a clue on these problems. Look for diameters. If this is a diameter, I know that this total length is 180, right? So if I had to find PQ, I could subtract 81 and 73 from 180. That would give me PQ. So the diameters help you. Then I would know this is 81 and I'd know PQ. Then I can find this angle because I subtract these two from 180 and I get that angle, and so on. All right. So MN. What would MN be? Anybody? Eric?
73.
How'd you get that, Eric?
The angle symbol says that 73.
Okay, yeah, the angle across the vertical angle, right? We have vertical angles. This angle is 73. This is the vertical angle, so that's 73. So MN is 73 because it's the same as the central angle. NQR. What's the measure of NQR? Jacob, what do you think? NQR, what's its measure? What is NR? It's the diameter. NQR is the arc intercepted by the diameter. So NQR is 180. NQR is 180. All right. PN. What's the measure of arc PN? Logan Calloway. Yeah, it's the same as the central angle. So PN is 81. QR, what would QR be? Logan Liffick. 73, same as the central angle, right. QMR. Okay, so that is a major arc, right? QMR. That's sort of a challenging one. Anybody have an idea how to find QMR? QMR. Okay, so for QMR we know that this our QNR, that's 180. And then we've got this, this is 73. So this side is 180, right? This half of the circle would be 180, the unshaded half. So I take 73 from 180 and I would get that this is 107, right? Because 107 and 73 add to 180. So then I have to add the 107, right, to get QMR. So it'd be 180 plus 107, so that'd be 287. QMR is 287. Everybody follow that? All right. Let's do PRN. P R N is this arc. That's PRN. Okay. How would I find its measure? Anybody? PRN? Gauge?
360 minus 81.
Yeah. Good. I was thinking of it, you'd have to find QP and add 180 and 73 QP, but that's the simplest way. So we would do PRN is 360 minus 81, right, which would be 279, right? 279 degrees for PRN. We're not going to do 2 through 12. All right. Are there any questions on those that we just did? Everybody get the idea? All right. You're going to have to do that on the quiz. Okay, now find the indicated arc measure. So remember, these arcs mean that these segments, these arcs are congruent. Those angles are congruent. So how could I find QS? Any ideas how I could find QS? Yeah.
360 minus 52 and then divide that by 2.
Right. We take 360 minus 52. That's what's left of the circle, and then the circle's divided in half, so we divide that by 2. So that's going to be 308 divided by 2. That's 154. So QS would be 154. Okay. All right, number 2. Same concept, except we have to add some stuff after we get the arc. So we're going to take 360 minus 74 divided by 2. So that's going to be 60 from 74 is 14, so it'd be 286 divided by 2 equals 143. So, and we have to find LKJ. We know this is 143, so there's an additional step here. We have to add the 74 and the 143. So we take 143 plus 74, and we get 210, 217. 217 would be that angle. All right. Example number 3. How could I find x? Any ideas? How I could find x on example number 3? Okay, we've got vertical angles here, right? So that's 180 minus 80 minus 67. So that's going to equal to, so that's 180 minus 80 is 100, minus 67 is 33. So x is 33, and since it's a vertical angle, this would be 33. As this angle, right? This arc is 33, and so this is a vertical. Its central angle is 33, so the vertical angle, so x would be 33. Questions? Okay. All right. So